Imagine breaking your femur in the wild 50,000 years ago, an injury that should guarantee immediate death. Yet fossil after fossil shows ancient humans not only surviving this exact injury, but living long enough for the bone to fully fuse back together. In a brutally competitive prehistoric world, a broken leg meant you could not hunt, run, or escape predators. So how did people with zero access to modern medicine pull off what seems like a biological miracle? The answer reveals a side of human nature that completely changes how we think about our ancestors. Think about a wild deer that breaks its leg in the forest today. Within a few hours, predators notice the limp, track the animal down, and ends its life before nightfall. But when archaeologists unearthed a 50,000-year-old Neanderthal skeleton in Shanidar Cave in modern-day Iraq, they found something that broke every rule of wild survival. This individual had suffered a massive fracture to his arm, severe trauma to his leg, and was likely blind in one eye. Yet his bones proved he survived for decades after these injuries occurred. How could someone who could barely walk or defend himself survive in a world ruled by saber-toothed cats and extreme Ice Age winters? The immediate thought is that ancient humans must have possessed some unknown, lost biological ability to heal faster than we do today. But genetic testing on ancient bone tissue reveals their internal healing mechanics were virtually identical to ours, which means the secret was not hidden inside their bodies, but in the choices of the people standing around them.
When a human bone snaps, the body immediately forms a giant blood clot around the fracture to hold the pieces in place, while specialized cells rebuild the mineral structure. For that delicate rebuilding process to work, the broken bone cannot move or bear weight for at least 6 to 8 weeks.
If a hunter-gatherer was moving every few days to follow animal herds, holding a person completely still for 2 months should have been totally impossible. Picture a mobile tribe carrying all their heavy stone tools, animal skins, and children across rugged mountains while running low on food. Taking care of an adult who cannot walk means 2 active hunters must stop hunting, carry that person on a stretcher, and share precious food reserves with someone who cannot contribute a single calorie back to the group. From a pure evolutionary survival standpoint, helping an injured person seems like absolute economic suicide for the tribe. Yet nearly every ancient burial site ever excavated tells the exact same story. Archaeologists routinely find ancient human skeletons with fully healed fractures, showing that groups willingly chose to carry this massive survival penalty for months at a time. This brings up an even stranger puzzle, because early humans were not just keeping their favorite leaders or strongest fighters alive.
In a cave in northern Spain, researchers discovered the remains of a young girl who lived over 500,000 years ago with a severe cranial deformity that left her severely disabled from birth.
She could not hunt, gather, or contribute to the physical survival of her band in any way, yet the physical evidence proves the group cared for her and kept her well fed until she died in her early teens. This single discovery shattered the long-held belief that early humans only protected members who were useful to the tribe. If survival of the fittest was the absolute law of the ancient world, caring for a completely non-productive member should have driven those tribes to total extinction. But the exact opposite happened, as the human species grew stronger, smarter, and more dominant precisely as these compassionate behaviors became more common. This leads to a fascinating twist in evolutionary science, where caring for the weak turned out to be the ultimate weapon for human survival. When a tribe kept an injured elder alive, they were not just wasting food on a broken body, they were preserving a living library of critical knowledge. An old or injured hunter who could no longer run could still teach young members how to fashion intricate flint arrowheads, locate hidden water sources during severe droughts, or predict weather changes by watching bird migrations. The physical body was broken, but the brain remained an irreplaceable resource that kept the entire community alive during crises.
Keeping an injured person motionless created a brand new problem that almost always proved fatal in the ancient world. When a person stays completely bedridden on the bare ground for weeks, severe pressure sores develop, dangerous infections set in, and the limb often rots or becomes permanently crooked.
To keep a broken bone straight enough to heal into a functional limb, ancient humans had to invent the world's very first medical technology. Imagine standing in a dark forest 40,000 years ago with no metal, no bandages, and no painkillers, trying to fix a friend's twisted leg. Early humans figured out that by tightly binding straight wooden sticks or thick tree bark around the broken limb using animal sinew or leather strips, they could create a rigid external frame. Archaeologists have found ancient skeletal remains where broken bones healed in near-perfect alignment, proving these primitive splints were astonishingly precise and effective. Creating a wooden splint is one thing, but managing the unspeakable pain of a broken bone without modern drugs is another challenge entirely. If an injured person twitched or thrashed around from intense pain, they would instantly disrupt the delicate bone fusion process and cause internal bleeding. How did ancient humans keep patients calm and pain-free long before the invention of modern anesthesia? They turned to the natural world around them, developing a deep chemical understanding of local plants through trial and error. Deep inside the dental plaque of ancient Neanderthal teeth, scientists discovered microscopic traces of poplar tree bark, which contains salicin, the active ingredient used in modern aspirin. They were actively gathering, chewing, and administering specific wild plants to relieve pain and reduce swelling thousands of years before pharmacy labs existed. Even with splints and natural pain relievers, open fractures where the bone pierced through the skin almost always triggered deadly bacterial infections. In a world before antibiotics, a dirty wound meant swift death from sepsis within a matter of days. Yet ancient human remains show clear evidence of surviving massive compound fractures that involved major skin tears and exposed bone. This brings us to another surprising twist in ancient medical care. Because early humans were using effective natural antibiotics long before Alexander Fleming discovered penicillin in a lab. The same dental plaque studies revealed that ancient humans were eating specific types of moldy vegetation and wild mushrooms known to produce natural antibacterial compounds. They were not just cleaning wounds with fresh water. They were applying rudimentary antibiotic poultices directly to open injuries to keep killer bacteria at bay. Healing the bone was only half the battle, because once the bone fused, the surrounding muscles were completely withered away from months of disuse. A person who had been bedridden for 8 weeks could not simply stand up and resume hunting woolly mammoths the next morning. They needed weeks of gradual rehabilitation to rebuild muscle strength and learn how to walk again on a newly reformed leg. Think about the immense patience required by a hunter-gatherer group to support someone through this long, painful recovery process. Tribe members had to assist with basic physical therapy, helping the injured person stand, lean on improvised wooden crutches, and slowly regain their balance day after day. This level of long-term care required a complex social structure where tasks were divided, allowing some members to forage while others acted as full-time caregivers. This deep level of social cooperation creates a stark paradox when compared to other highly intelligent social animals in the wild today. Chimpanzees and wolves show empathy and will occasionally share food with an injured group member for a few days. However, if that injury prevents the animal from keeping up with the group for weeks on end, the pack eventually moves on and leaves the injured individual behind to die. Why did humans cross this psychological threshold when other highly social primates did not? The turning point seems to be connected to the moment early humans mastered the control of fire. Fire provided light and protection from predators, allowing tribes to set up semi-permanent campsites instead of constantly staying on the move. Around a glowing campfire at night, an injured human was no longer a dangerous liability that held the group back from escaping predators. The campsite became a safe sanctuary where an injured person could rest undisturbed for weeks, while the rest of the group ranged out to gather food and returned every evening. Fire effectively bought human beings the extra time needed for complex biological healing to take place. This prolonged resting period had an unexpected side effect on human culture and communication that no one could have predicted. While resting around the fire for months, injured individuals spent endless hours talking with caregivers, telling stories and teaching young children the history and lore of the tribe.
Many anthropologists believe that caring for the sick and injured actively accelerated the development of complex human language and storytelling. The legendary anthropologist Margaret Mead was once asked what she considered to be the very first sign of human civilization.
Instead of pointing to a clay pot, a stone weapon, or a primitive farm, she held up a 15,000-year-old human femur that had been broken and completely healed. She explained that in the animal kingdom, a broken leg is a death sentence, so a healed human femur is absolute proof that someone took the time to protect, feed, and nurse that person back to health until they recovered.
This means that civilization did not start with grand cities, complex laws, or monumental stone structures built to glorify ancient kings. Civilization began the very moment an ancient human saw a fellow tribe member lying in the dirt with a broken leg and decided to stay behind to help them instead of running away. Every modern hospital, life-saving medicine, and active community care we see today is just a direct continuation of that single compassionate choice made in a dark cave tens of thousands of years ago. When you look back at how our ancestors survived broken bones, it forces you to reconsider what truly made humans the most dominant species on Earth. It was not our sharp claws, our incredible running speed, or our physical strength, because compared to wild animals, our bodies were fragile and easily broken. Our true superpower was our willingness to absorb a massive disadvantage just to keep each other alive when we were at our absolute weakest.